Hello class, welcome to Empowerment Technology. So in this video, we're going to learn how to use Microsoft Excel for our chi-square test. So here I have an example. So for example, we have 50 students who were asked about their preferred TV programs. So the responses are shown in the table. So in this table. So we have three type of TV programs included. So we have the K-drama, we have the documentary series, and we also have the anime. So our one of the statement of the problem is that we would like to find whether there is a significant relationship between the gender and the TV program preference. So we would like to know whether is the TV program is the TV program preference dependent on the gender of the viewers. For example, we have here male and female. So, mas madami ba yung mga male na nanonood ng anime? Mas madami ba yung mga nanonood na female ng K-drama? So, we would like to know whether the type of TV program is dependent on the gender. So, to do that, so for example, we have here the table for our responses. So what we need to do is to create a contingency table. So this table is known as contingency table. So this is the contingency table for the observed value, and we also need to create a contingency table for the expected value. So the observed value are the actual frequencies of the respondents. So meaning, if you count the responses, for example, the number of male students or male that responded anime, so this is the number of males. So we have 16 male students who responded anime. There are 3 respondents, female respondents, who chose anime, and so on. So this is the actual count of the responses of your respondents. For the expected value, this is the hypothetical value. So this should be the value that we are expecting. That's why expected value. So to get the expected value, we use a formula. So what we do here, what we use to solve for the expected value is we multiply the row sum or row total times, wait lang. So we have here the row sum or row total times the column sum divided by grand total. So row sum here is, for example, this one. So 24, this is one of the row sum. So for example, you would like to get the expected value for this row, then you need to use their corresponding row sum. So 3 plus 7 plus 14 is equal to 24. So if you would like to get the expected value for the second row, then you need to use the corresponding row sum for that row. So the same with the column. For example, you would like to know the expected value for this column, then you need to use the column sum that is corresponding to this column. So for example, 3 plus 16 is 19. So therefore, for this one, we have here 24 times 19 and then divided by the grand total. So the grand total is the overall total. For example, 24 plus 26 is equal to 50. 19 plus 11 plus 20 is equal to 50. So that will give us the expected value. So in Excel, we don't have chi-square in our data analysis. So last time I showed you how to use the data analysis, but in Excel we don't have chi-square test in our data analysis toolpack. So therefore, we need to make use of the function for chi-square. So we have here two functions that we can use in order to solve for the probability value and for the chi-square value. Also, we have here the equation or the formula for finding the degree of freedom of this contingency table for this chi-square. So for the decision making, we will go back to this part after we solve for the chi-square value. So um, have let's now have a demonstration. So first, we need to create a contingency table. So to create a contingency table out of all this data, so for example, we have 50 respondents. So we need to create a contingency table to count the frequencies for each of the variables. So to do that, just select anywhere inside the table and then go to insert tab and then select pivot table. So after selecting the pivot table, change the table and range value. So here we will select our first variable is gender, our second variable is type of TV program, and then we need to select all of the responses under gender and type of TV program. And then you can select new worksheet if you would like to create a pivot table in new worksheet, or you can also create the pivot table in your existing worksheet. So in this case, I would like to create a new worksheet. So select OK afterwards. So we have now here a menu for the pivot table. So what we want to do is to arrange the variables. So for example, I would like to place the gender in the rows. So therefore here, the gender will appear for the first row. We have here female. Second row, we have here male. So for the type of TV programs, I would like it to be in columns. So therefore, I have here for the TV program, we have here anime, documentary series, and then K-drama. So what I would like to do next is to place the values, the frequencies, or the count. So therefore, I can just select any of these two, so gender or type of TV program, and then drag it to these values. And then it will automatically create a contingency table or a frequency count of the responses. So we have here our what do we call this, frequency for female students which responded anime, for documentary series, and for K-drama. So male students, number of male students which responded anime, documentary series, and K-drama. And this is the column total for anime, the column total for documentary series, the column total for K-drama. This is the row total for female, the row total for male, and then the row total, the grand total for both the female and males. So afterwards, you can copy this table, and you can now copy this table and paste it as value. So for example, you would like to paste it here. Ayan. So therefore, select the cells where you would like to paste your table, and then right click and then paste as value so that it will be editable. So let's say for example in this part, yan. Okay, so you can now edit the labels. For example here, for example, this column is for the row labels. So this is for the gender or sexual orientation, and this is for the type of TV program. So type of TV programs. So you can add a border if you would like, and add a color in your cells para hindi kayo malito. Ayan. So this is now our contingency table for our observed values. So we have two rows, so female and male, and we have three columns, which is anime, documentary series, and then K-drama. So the total for female is 24. The total for male for the row is 26. For the column of anime, 619. We have documentary series 11, K-drama is 20, and the grand total is 50. So we can now copy this one and create our table for the expected value. So paste ulit natin. So just remove the values inside your table. So this one, just remove these values in your expected value, because we need to solve for the expected value. So again, the equation or the formula for the expected value is that expected value is equal to row sum times column sum divided by the grand total. So here, for example, you have your equal sign. So row sum, so open parenthesis, row sum times column sum, close parenthesis, divided by grand total, which is 50. Enter. And then do the same to the others. For example, in documentary series, we have your equal sign, open parenthesis, row sum times. So since we are now in the second column, therefore the column sum for documentary series is now 11, and then divided by grand total, enter. And then the same for the K-drama, so equal sign, open parenthesis, row sum times the column sum, close parenthesis, divided by the grand total. So in our second row, so since we are now in the second row, we will now use the second row total, which is 26. So instead of 24, so here we have your equal sign, open parenthesis, the row sum divided by times the column sum divided by the grand total, and then do the same to the others. So you can explore and apply the absolute and relative referencing so that you can copy the formula in this part. So if the contingency tables becomes too big, for example, it has many rows and many columns, then you can apply the absolute and relative referencing so that you can copy the formula from one cell to the other cells and to the other columns or rows. So we will just finish this one, and then we will proceed to the next step. Okay, so after creating the observed values and the contingency table for the expected values, we need now to solve for the probability value. Probability value, or also known as the p value. So to get the p value, we need to use the function equal sign chi-skew dot test, or chi-square dot test. So chi-skew dot test, and then open parenthesis the actual range. So let's copy this one so that we will have a guide. Okay, so this is the what do we call this, the sequence or the syntax for the chi-square function for the p value. So here we have your equal sign, and then followed by chi-skew dot test, open parenthesis for the actual range. So we have here our first table, which is the observed value. So the observed value contains the actual frequencies for each of the variables. For example, here we have 3, 7, 14, 16, 4, and then 6. So that those are the actual values. So therefore, we need to highlight for the actual range all the cells in our observed values that contains the frequencies. So we have here 2 rows and 3 columns. And then for our next argument is we need also to include the range for the expected value. So in this case, we have here this one, 2 columns and 3 columns and 2 rows also, and then close parenthesis, and then enter. So this is now our p value for this data. So next is we need to solve for the degree of freedom, also known as df. So the degree of freedom again is ito. So we have here equal sign, so the number of row minus 1 times the number of column minus 1. So how many rows do we have in this contingency table? So we have 2 rows, male and female. So we have 2 rows, and we have 3 columns, anime, documentary series, and then K-drama. So therefore, we have here equal sign, and then number of rows is 2 minus 1 times number of column is 3 minus 1. Sorry, wait lang. So we need to, I forgot to include the asterisk. So to multiply, we need to use the asterisk. So therefore, the degree of freedom is equal to 2. And then next, we need to know the critical, or the chi-square value rather. So to solve for the chi-square value, we need this function. So the chi-square value, or the x raised to 2. So x squared value, which is, to solve for the chi-square value, we use the function chi-skew dot inv dot rt, open parenthesis, the probability value, and then comma, the value of the degree of freedom. So here we can now enter our function. So chi-skew dot inv dot rt, open parenthesis. So our probability is our p value, which is 0.0016177. So you can just select the cells that contains this value, and then the value of our degree of freedom, which is found in this cell J28, and close parenthesis, and then that will now give us the chi-square value. So afterwards, the critical chi-square value cannot be um, given by the Excel. So we need to use the chi-distribution table. So I have here the chi-distribution table. So what we need to know is that, let's say for example, that our alpha value, significance level, also known as the alpha value, let's say for example that this is equal to 0.05 or 5% level of significance. So to know the critical value, we need to know the alpha value to be used. So the alpha value is up to you. So whether you would like to use 0.05, 0.01, 0.1 or other alpha level values, and you need to know the degree of freedom. So using the chi-square distribution table, so for example here we have a degree of freedom. So let's highlight this one. For example, we have a degree of freedom that is equivalent to 2, and the alpha value we used is 0.05. Then the value of our critical chi-square is 2. Here we have here 2, and then 0.05. So therefore the critical chi-square value is 5.99. So just so how about the decision making? So for the decision making, we can compare the p-value. We can compare here the p-value versus the alpha value, or method number 2 is we can compare the chi-square value and then the critical value. So chi-square versus the critical value, or p-value versus the alpha value. So for method number 1, if our p-value is less than or equal to the alpha value, we need to reject the null hypothesis. So let's say for example, so let's create a formula for this one. So sabi dito, if, so we can use the if function. So if our p-value, for example, where is our p-value? So for example, this one, if our p-value is less than or equal to, so less than or equal to the alpha value, which is 0.05. In this example, we use 0.05. Then we reject the null hypothesis. So reject the null hypothesis. So if not, the return value should be do not reject the null hypothesis. Then enter. Okay, so if our p-value is less than or equal to the alpha value, we reject the null hypothesis. And if our p-value is greater than the alpha value, then we do not reject. So since in this example our p-value, our probability value is less than the alpha value of 0.05, then we need to reject the null hypothesis. So this means that there is a relationship between the gender and your there is a relationship between the gender and the type of TV program. So at a significance level of 0.05, there is the TV program, we can say that the TV program is dependent on the gender dependent on the gender. So we can also use the critical value of chi-square and the chi-square value in our decision making. So here, if the chi-square value is less than the critical value, we do not reject. If the chi-square value is greater than or equal to, then we reject. We reject the null hypothesis. So we can also automate this by using the if function. So sabi natin, if our critical value, so if our chi-square value, so if our chi-square value is less than our critical value, then we do not reject the null hypothesis. So our second condition is that if the chi-square value is greater than or equal to the critical value, then we reject the null hypothesis. So here is our two decisions. So as you can see, we have the same decision. So whether to use the p-value and then the alpha value, or comparing the chi-square value and the critical value. So both suggest or both indicates that we need to reject the null hypothesis. So therefore, in your chi-square also, it is important to state your null hypothesis. So again, for the null hypothesis, for the chi-square, the statement for the null hypothesis should always contain this. Ayan. So there is no relationship, there is no dependence, for example, or maybe gender is independent of TV program. So you should have here the negative statements for the null hypothesis, so no relationship. While for the alternative relationship, you should have the positive statement, which is there is a relationship. So that is the format for creating the null and the alternative hypothesis for the chi-square test of independence. Okay, so I hope you learned something in this video. So that's all. See you in our next video.